Hello viewers, welcome to our channel, and today we are going to look at the decision making under risk. Last time we spoke about the introductory aspect and we looked at some of the key items that we are going to be looking at. But for today, our main focus is on the computations, and we had left a simulation which we are going to start with. It's a classic example that will help us to get the basics that will help us to handle the question paper numbers or the past paper numbers. So without wasting more time, let's dive in and see what we have. But we are going to be using this one question to do both methods. We say a decision making under risk, we use two different methods. One is the expected value, and that expected value, we say we get the payoffs, we multiply it by the different probabilities that have been given to us. So we get the payoffs for a given state of nature, we multiply by their corresponding probabilities for the different periods. And when we sum them up, we should be getting the expected value or the expected monetary value or the expected payoff, whichever you call it. And the other aspect, we looked at the decision trees. When we use the decision trees, we said most of the times the examiner is going to be focusing on the examination, the decision tree for examination purposes. So we want to look at this one question. It's a classic example, it's a basic example that will help us pick the basics or the concept that we need. So we are going to look at this. We do both methods. We're going to look at the expected payoff or the expected value, and also we look at the decision tree. So let's go through the question and see what we have. They are saying that consider the table below showing the states of nature and their alternatives. The states of nature, we have them. They have also given us the alternatives. Alternatives, we have projects, project 1, project 2, and project 3. Then we have also the probability. The states of nature, we have diminishing, static, and expanding. Those are the states of nature that we have. They have given us the different payoffs. These figures you are seeing here, the 1,000, sorry, the 100, the 200, the 1,000, 0, 500, 600, 180, 190, 200. These are the payoffs or the expected outcome for each of the projects, depending on the state of nature that has been given to us. Then they have given us the probability for diminishing to 0.4, static is 0.3, and expanding is 0.3. One of the key things that you need to note here is that you may find that in some exams they have not maybe given you the probability, let's say for this one, and they have not given it to you. What you have to know is that probabilities, they are always equal to 1. When you sum them up, they give you a total of 1. If they are in percentages, then they should give you 100%. So if you sum these ones, if at all this one was not given, if you add this plus this, you less from 1, you will be able to get the remaining probability. Even if they have not given you this one, you add this plus this, you less off that result from 1, you will be able to get the remaining probability for a given state of nature. So they are said that based on the expected value, which of the above project is the best. In other words, we want to see which of these is going to be the best alternative that we should undertake. The alternatives we have the project 1, project 2, and project 3. We said with these projects, you may find that we said with these alternatives, we say those are the things that the decision maker is going to do. In other words, These are going to be within the control of the decision maker. It's the decision maker to know which kind of project he or she is going to undertake. But it is always these states of nature, which are the things that are going to be outside the control of the decision maker, that will affect or that will determine which project they should get, depending on the results or the outcomes, because the state of nature always dictates what is going to be the likely outcome. If, let's say, you're a musician and maybe you had a show, and you find that the same date you are having a show, it is going to be raining, you'll find that you will not be making profits out of the show, because there are going to be very few people who are going to be coming in, than at the point when it is going to be a sunny day, or it's not going to be, when rain is not going to be there. So weather dictates whether you are going to make profits or you are not going to make profits. And that weather, if it is going to rain, that one you have no control about it. So it is something that will affect the results that we may get, but it is outside our control. So those are the things that we looked at. For those who haven't picked it right, you may go to our first video about the risk and uncertainties, where we explain all these aspects. But for this case, we said we started with the decision making under risks. Then we shall also look at the decision making under uncertainties. And when that is done, we shall conclude the topic. But let's first finalize the decision making under risks. So that's what they have given us. They have given us the table, they have given us the information that is there. So we want to use the expected value to know which project is going to be better. What you have to understand is that the same way we did these risks under quantitative techniques, even in there is a part in financial management that does the same thing. The same way we did it is the same way we are going to do it here. It's only that here we are going to do it and we make sure that we advise or we make a decision. We help management to make a decision. Because in the other QT paper or the quantitative techniques paper at level 1, you may just be required to compute these values and you just get the values and you stop there. But for management decision and control, we make sure that we provide decisions to the different decision maker, whoever is concerned with the information that we've prepared. So let's try to look at our Excel sheet and we'll see what we can have. So we go to our Excel sheet. We are going to look at the decision making under risks, but we are going to do computations for both methods, the expected values and the decision tree. So we first start with the expected values. We said expected value is the same as expected monetary value. Monetary value. And we said it is the same as expected payoff. Expected payoff. They all mean the same thing. So it is what we are going to be looking at. We are not going to repeat the formula here because we said get the probabilities, we get the payoffs that we are, or the outcomes that we are going to get for every item, we multiply by their corresponding probabilities. And that's what we are going to be doing. So here we said we are just going to look at this. We just get these outcomes because for project 1, the outcome is going to be 100 if it is in the state of diminishing. If it is static, then we are going to have 200. If it is expanding, we are going to have 1000. So we shall just get this 1000 times the probability 0.3. We add 200 times 0.3. We add 100 times 0.4. We add that for that project. And we repeat the same thing for project 2 and project 3. And that's all that they want us to do. So let's go to the Excel sheet and we'll finalize this very fast. So project one is going to be the outcome, the payoff, which is 100. We multiply that by the probability of 0.4. So we can just put everything here in the bracket. We just put everything in the bracket. So when that is done, we add the outcome from the diminishing, which is 200, times the probability, which is 0.3. Because this is the probability, these are the number of chances for us to receive 200. Those are the chances, the number of chances that we have for us to get that 200. So for the last one, we have 1,000. 1,000, we multiply that by the probability, which is 0.3. And when we do that, when we sum everything, we shall be getting 400. But now this 400 is going to be in shillings. That is the symbol that represent Ugandan shillings. So we go to project 2. Project 2. Project 2 is also going to be equaling to the 0, which is the first outcome that we have. We multiply by the probability, which is 0.4, close the bracket, then we add the next state of nature, which is static. Static is giving us 500. 500 will multiply by the probability of 0.3, and that will give us that. So we add this to the last state of nature, which is 600, multiply this by 0.3. So we close the bracket and we get the final figures there. The final figures, we say these figures are going to be in shillings. So when we do that, we shall get 330 shillings. So it is this that is going to be the outcome from that. So we go to project 3. Project 3 still we do the same thing. We get the expected payoff. This is 180. We multiply by the probability of 4. Because that we add 190. That is the expected payoff. That is the payoff. We multiply by the probability of 0.3. We also add the last one, which is 200. We multiply this by 0.3. That's the probability. So this will give us the final amount of, this will give us 189 shillings. So the decision point here, we said the decision point is going to be, we pick the best. To pick the best project, we look at the project that has the highest expected payoff. And we are seeing the one that has the highest is this project 1, because it has 500. So the decision here we are going to take is, maybe I can just put it in yellow. That is the one that has the highest, that has the highest expected payoff. So what this means is that we are going to say, if you are to advise, if we are giving the advice or conclusion, stock advice, we say that the best, because that's what they wanted. They wanted to see the best project or the best alternative. The best project is project 1. since it yields the highest expected payoff, expected value, or the expected payoff of 400 shillings, which is higher or as compared to that of project 2 and project 3. That is the conclusion that they wanted us to do. It was very simple. It just needed something small that we needed to do. So that's as far as the whatever the expected value is concerned. That's how we make sure that we get to do that. But we need now to look at the other approach, where we are going to be looking at the decision tree. The decision tree is the one that we are going to look at here. The decision tree, we see how are we going to be able to draw this. But since we have this, since we are just doing it in Excel, we're going to just get to just share the sheet that shows the decision tree where we did the computations. But for the decision tree, we said it has the decision points, and those decision points are represented by a box. Then the state of nature are the ones that are represented by circles. So if you look at the same example we did, and we assume maybe the examiner told us to just draw the decision tree, to use the decision tree to determine which project has the best, or will be the best, or which project that they should choose from the different alternatives, because we have project 1, project 2, and project 3. So we had to come and draw our decision points. When we draw these decision points, we make sure that we represent those projects or those different alternatives that we have, or that the decision maker can undertake. We can look at the final point here. We said if you are going to be basing on the same question, this one, we just go to the decision tree. Let me just share the decision tree, how it looks like. This is how the decision tree looks like. First, it has the decision points. We say these boxes, they are the ones that are going to be representing the decision points. And these circles you are seeing, they are the ones that are going to be representing the state of nature. Then the final figures we are seeing this side, they are the same figures that we've computed using the expected value. We are going through this so that we can be able to get these figures, because these are the same figures that we computed when we use the expected value. The other one is more of a mathematical approach. This one we have to look at a pictorial view or a diagram. This one gives, it's more elaborative. Someone, even the person who doesn't have the accounting background, can be able to understand the decision tree. So the key point here is that we have a box that will be representing these decision points. Then we have a circle that will be representing the states of nature. Those are the key important items, because what will come next will be the outcomes. Of course, the outcomes of the different projects vis-a-vis their different states of nature. So we start by drawing the decision, the box that will represent the decision point. And this decision point is going to give us project 1, project 2, and project 3. Those are the 3 different alternatives that we have. So after showing those different alternatives, then we have to see that each alternative has its own state of nature. Because we've seen for project 1, we have diminishing, just like the way you are seeing from here, from the question, this one. We are seeing that project 1 has diminishing, has static, has expanding as their different states of nature, and we have their corresponding values. So what we do here is that we represent each project is going to be having its state of nature. The state of nature is only one. There are 3 different states of nature that we have for project 1, even for project 2, and the one for project 3. That's why we have a one circle that is representing the different states of nature. We have the diminishing, static, and expanding. So we are seeing that this circle that we have for each project, we are seeing that it has extra lines or extra 3 lines that are representing the states of nature that is going to affect the same project. Because we are seeing that every project has the same states of nature. Project 2 has a diminishing, has a static, has an expanding state of nature. So we want to see what will be the outcome for these different items. So we look at them into 2 stages. We see these outcomes, and we see that these outcomes, they are the ones that are going to determine whether we are going to select that project or we are not going to select that project. Just like the way I've said, that if it is a rainy day and you're a musician and you had your concert, you may find that you find yourself making losses because the rain will scare people from coming to your concert. So that's why we are seeing the different alternatives. The state of nature is something that is not under the control of the decision maker. So it is something that is going to be hindering our outcomes. So we are seeing that if project 1 goes into a diminishing point or state of nature, we are going to have a payoff of 100. But the probability of having that 100 is 0.4. In other words, there are 0.4 chances of us getting a payoff of 100 from the diminishing point. For static, if the state of nature remains neutral, we are seeing that we may have a payoff of 200, and that payoff is represented above this line. These dots you are seeing, they don't represent anything, but I've just put them there to show that where the diminishing ends, we have the outcomes. These are the possible outcomes with their corresponding probabilities. So this, if you get this, the 0.4, the probability you multiply because if you get the payoff, you multiply by the probability, you are going to be getting the expected value for that diminishing state of nature. You also get the expected value for static state of nature, and at the same time, you get the expected value for the expanding state of nature. So when you get all of that, you add them to get the overall expected value for the project. Remember, these expected values, they are for these different states of nature. The static has a unexpected value of 40. This is what we expect to get in terms of the amount, 40 shilling. Then for static, we are expecting 60 shillings, and expanding, we are expecting 300. Because we've taken the probability, these are the expected values. So we add these different expected values from the different states of nature to get the overall expected value of the project. In other words, when you add the expected value that we are getting from diminishing, you add that from static and the one from expanding, you will be getting the overall expected value of the project, and that's what we want, or for that alternative. So it is the same thing. We do the same thing for project 2. We also get their expected value for the different states of nature. This one, if it is diminishing under project 2, we expect the payoff to be 0. That's what they have given us in the question. But the probability of getting a 0 is 0.4. These are just forecasts, because if someone gives you the chances of occurrence, it means they are predicting on something that it never happened, or it hasn't happened yet. So these are just helping us to make a decision that if you go into this and you experience certain states of nature, you are going to be having the overall as this. So that's why we are doing for each and everything. Then after that, we get the overall. And still, the decision point is the same. We do the same thing. We check the one that has the highest expected value. And the highest expected value is coming as the 400. So you are seeing that if you add all these expected values from the different states of nature, you find that the overall is going to be, we pick the highest overall expected value, and you are seeing it is giving us 400 shillings. So that means when you have to make a decision, or if you have to advise the organization on which project to undertake, or on which alternative to undertake, they will go with project 1, because it is the one that gives us the highest overall expected value of 400 shillings. So that's basically what we were required to do as far as decision making under risk and using the different methods, the expected value and the decision tree. But we said most of the times they are going to be asking us to use the decision tree, because this decision tree helps even the person who doesn't have the accounting background to understand what we are doing. So we are going to look at another question from March 2022, question 3, question 3A, Roman 2. That will give us a highlight of what we can have as far as decision trees are concerned, because this was just a basic example. So we want to look at the past paper number and we see what we can easily get. So that's all that we needed to know. I'm going to make sure that at least we cover the March 2022, so that we can be able to get a wider coverage on how we can be able to draw the decision trees. But just like the same way you are seeing what we did here, it will also be shared like the way it has been shared here. So thank you for watching. For those who haven't subscribed, please subscribe and help us to improve the channel, and also get notified whenever we upload some of these new videos, because that will keep you informed on the different topics that we are going to be handling at the different times whenever we are uploading the videos. So thank you for watching. Let's meet in the next video where we are going to be talking about the March 2022 question 3A Roman 2 that will give us an extra knowledge on the decision trees